These are the video notes for section 1.2. I'm going to fill them out and say a couple things about each portion. Please fill in as we go along together. You can pause the video at any time if you need to add anything else in. So the first part we have is a line segment, or segment is a portion of a line with two end points. If we look at the segment below, A and B are the two endpoints, as it says right here. We can name this segment in two ways. We can name it as segment AB with a dash over it, or we can name it as segment BA. Just as with a line, the order of the 2 points does not matter for a line segment. The length or measure of the segment is written as, again, the order doesn't matter, but I'm going to write AB. And notice this does not have anything above it, like AB or BA up here. These are segments. AB right here is referring to a length, a distance, a measurement. So as we go further down, if you want to pause right now and write all this down, go ahead. So next we have segment addition. So this says if point M is between points P and Q, then P, Q, and M are what we call collinear. Collinear. So as we go further down here, we're going to use the measurement notation like we did up here with AB, not the segment notation. So we are saying that the measure of PM plus the measure of MQ is equal to the measure of PQ. So to show a numerical example below, we're going to use this segment here of RT with S as a point in between R and T. All three of these points, again, are collinear. So to find the measure of RT, we can say that RT is equal to the measure of RS plus the measure of ST. So we are now going to substitute in the value for RS in right here. So we're going to carry the RT down. We're going to substitute in the value for RS. So we're going to write this 2.0. We're going to add in the units at the end. We're going to write in 2.0 plus, we're going to substitute in the value for ST, which is 2.5. So 2.0 plus 2.5 gets us 4.5. And again, remember our units, this is centimeters, right? Centimeters, so our units at the end are centimeters. So RT is 4.5 centimeters long. As we go on to number 2, BC is this entire segment, it's the smaller segment actually, excuse me, the entire segment is AC. So we're going to write this as AC equals AB plus BC. We're going to sub in some values, and then we will have to do some subtraction in a little bit. So AC here is 6. So 6 equals 2 3/4 plus BC. So to find BC, we're now going to have to subtract off 2 3/4. Remember, what we do to one side of the equation, we have to do to both sides of the equation. So that is now gone. 6 minus 2 3/4 is 3 1/4. And that is BC. And we're going to add in our inches here. Sorry, I didn't leave too much room for that. That is inches. 3 1/4 inches is equal to BC. So we now have a few versions of this with some algebra. So we have some x's in here. So RT is the whole segment. So if we draw this out, it's saying S is between R and T. So R is here, T is here. We can put S anywhere in the middle we want. It is not saying S is a midpoint. So we are going to place S there. All right, so we placed S anywhere between R and T because it just says S is between R and T. It does not say that S is a midpoint of R and T. So we placed S here. We were saying that RS is 5x and ST is 3x. I am totally 100% fine if this is not to scale. We know 5x should be bigger than 3x, but that just didn't happen how the diagram came out. We know that RT as a whole is 48. So we're going to set up our equation here just like we did above. You see how here we have RT equals RS plus ST. We're going to set that up. So we're going to say RT equals RS plus ST. So RT here is 48 equals RS, which is 5x, plus ST, which is 3x. So we're now going to combine our like terms. We're going to keep this 48 exactly the same. Bring this down, equals 8x. Now remember, we're going to divide off the 8's on each side to get x by itself. So we're now going to say that 48 divided by 8 is 6 is equal to x. So we are not done, because remember it says find the value of x and RS. So if we know x is 6, we know RS equals 5x equals 5 times 6, which is equal to 30. So we have our RS, we have our x, we are now done. We're going to do the same thing for 6. We just have a binomial here instead of a monomial. So it's the same kind of problem. We can draw it out again. I highly recommend drawing it out again. We have R on one side, T on the other side, and S anywhere we want in between them. Again, if it's not scaled, that's fine. So that's 2x. ST is 5x plus 4. And all RT altogether is 32. We're going to write out our equation again. We're going to say that RT equals RS plus ST. RT is 32. RS is 2x. ST, remember this plus sign is still here. Plus sign comes down. ST is now 5x plus 4. So we are now going to combine our like terms on this side first. So 32 equals 7x. We drop the parentheses, plus 4. We're going to subtract the 4 from both sides because we want to undo our addition before we undo our multiplication. So we get 32 minus 4 is 28 equals 7x. Sorry, I'm running out of room here a little bit, so divide by 7, divide by 7. We have x equals 4. So this is our x. Remember, we also need to find RS again. So RS equals 2x equals 2 times 4 equals 8. So we found RS, we found x. We're now done with this problem. Great. You now should be on the back side of the sheet. Our first definition here is congruent segments. So congruent segments are segments that have equal measures, right? They have equal measures, which means if AB was, let's say, 4 centimeters, EF would also have to be 4 centimeters. So to say that the two segments above are congruent, AB is congruent to EF, we are going to write this as AB with that little dash over it, right? This is a segment. This is segment AB, not measure of AB. Is congruent. We have this little squiggly sign over the equals. This is a congruent symbol. Is congruent to EF with the dash over it. All right, so we were saying that segment AB is congruent to segment EF, which means that the measure of AB is also equal to the measure of EF, right? That's definitional, that they have equal measures. So we will also put slashes on both segments to show congruence. These slashes usually look like this. So one mark, then a mark on that one, right? So we put a mark on AB to show that it was congruent to EF. Any other segments with one mark in the same diagram, it has to be the same diagram, that have one mark, we would say are congruent to AB and congruent to EF. So we have two examples below here. We're going to determine whether each pair of segments is congruent. So the first one we're looking at here is AB. I'm going to kind of shade in this segment here. So this is AB. So AB, and the next one is CD. So CD is right here. So AB is 5 centimeters, right? 5 centimeters. DC is also 5 centimeters. So these two fill the requirements of having equal measures. So we can say, yes, AB is congruent to DC. Sorry, this should say CD. But DC and CD are congruent to each other. So that's okay. So AB is congruent to CD. All right, so on this next triangle here, do you see these marks on XY and XZ? These are saying these are congruent to each other, but we are looking to see if XY, this one here, is congruent to YZ, that one there. So we can use our formula here. We can set these equal to each other. We can get not a formula. We can set up an equation that 3x plus 5 is equal to 5x minus 1 because xy is equal to yz. So these we can set equal to each other. I like to move my x's before my numbers, so I'm going to move 3x. Again, what I do to one side, I have to do the other side. That's gone. I also like to move the smaller x, so I get 5 equals 2x minus 1. Now we need to add the 1 to both sides to get the x's by themselves. So cross that out. 5 plus 1 is 6 equals 2x. Now our final step is to divide by 2. So 6 divided by 2 is 3. That is our x. So now we're going to check yz and see what this length is here. So yz, we have 9 times 3 divided by 2. This equals yz. 9 times 3, this equals 27 divided by 2. 27 divided by 2 is 13.5. Sorry, I'm going to bring that paper up for you. This is 13.5. So xy is what we need to see if it's equal to yz, or it is congruent to yz. We need to see if their measures are equal. xy is equal to 3 times, we found x was 3 here. 3 times 3 plus 5. 3 times 3 here is 9 plus 5 equals 14. So now we can say officially no, xy is not congruent to yz. All right, I will see you all in class on Thursday.